Picture this, a sleek starship gliding through the cosmos, stars streaking past like fireflies, as humanity ventures to a distant world orbiting a far-off sun. It's the stuff of sci-fi dreams. Think Star Trek's Enterprise or Interstellar's Endurance. But is interstellar travel just a Hollywood fantasy? Or could it one day become reality? Let's dive into the science, the challenges, and the wild ideas that might just carry us to the stars. The dream of the stars, humans have always looked up and wondered what lies beyond. From ancient stargazers to modern astrophysicists, the cosmos calls to us. Interstellar travel, venturing beyond our solar system to explore or even colonize other stars, is the ultimate frontier. Our closest stellar neighbor, Proxima Centauri, is 4.24 light-years away, a distance so vast it defies comprehension. Light itself takes over 4 years to get there, and our fastest spacecraft, the X-37B, would need about 80,000 years to make the trip. Yet the dream persists, fueled by both imagination and science. Why go interstellar? Beyond the thrill of exploration, there's survival. Earth won't last forever, whether it's climate change, asteroid impacts, or the sun's eventual expansion into a red giant. Colonizing exoplanets could be humanity's backup plan. Plus, there's the tantalizing possibility of finding life, intelligent or otherwise, out there. But the gap between dreaming and doing is a cosmic chasm. Let's break down the science and see what's possible. The physics problem: distance and speed. The biggest hurdle to interstellar travel is distance. A light year is about 5.88 trillion miles, 9.46 trillion kilometers. Our fastest probes, like Voyager 1, travel at roughly 38,000 miles per hour, 61,000 kph, a snail's pace on cosmic scales. To reach Proxima Centauri in a human lifetime, we'd need speeds approaching a significant fraction of light's velocity, 186,282 miles per second, or 299,792 kilometers per s. That's where Einstein's relativity kicks in. As you approach light speed, time dilation occurs. Time slows for the travelers relative to Earth. Cool in theory, but getting there is the issue. Chemical rockets, like those powering Apollo missions, are woefully inadequate. They burn too much fuel and achieve pitiful speeds. Nuclear propulsion, like Project Orion, a 1950s concept using nuclear explosions for thrust, could theoretically hit 10% of light speed, cutting travel time to decades. But even that's slow for crewed missions, and the engineering challenges, plus the political taboo of nukes in space, make it a tough sell. Then there's the energy problem. Accelerating a spacecraft to near-light speeds requires obscene amounts of energy. The equation ESMC2 means even a small mass needs colossal energy to approach light speed. For perspective, powering a modest spacecraft at 10% of light speed would require energy equivalent to thousands of nuclear bombs. And slowing down at the destination? That's another energy nightmare. Sci-Fi's warp drives or hyperspace lanes dodge this, but in reality, we're stuck with physics that don't bend easily. Promising concepts, from sails to wormholes. Despite the challenges, scientists have cooked up some mind-bending ideas. One is the solar sail, a lightweight craft pushed by sunlight or powerful lasers. The breakthrough Starshot initiative, backed by folks like Stephen Hawking, aims to send tiny sail-powered probes to Proxima Centauri at 20% of light speed. These nanocraft could arrive in about 20 years, snapping pics and beaming data back. The catch? They're too small for humans, and braking at the destination is still unsolved. Ion propulsion, used in NASA's Dawn mission, offers another path. It's efficient, using electric fields to accelerate ions for thrust. But it's slow to build speed. For crewed missions, we need something like antimatter engines. Antimatter annihilates with matter, releasing insane energy, potentially enough for near-light speed travel. Problem is, producing and storing antimatter is fiendishly difficult and costly. A single gram could cost billions, and a containment failure would be catastrophic. Now let's get weird. Sci-fi loves wormholes, hypothetical tunnels connecting distant points in space-time. General relativity allows for their existence, but they'd require exotic matter with negative mass to stay open, and we've never seen such stuff. Similarly, Alcubierre's warp drive theorizes a bubble of space-time that contracts in front and expands behind, letting a ship surf faster than light without breaking relativity. It's mathematically possible, but demands energy equivalent to Jupiter's mass. For now, these are tantalizing thought experiments, not blueprints. The human factor, surviving the journey. Even if we crack propulsion, humans are fragile cargo. A decades-long trip to Proxima Centauri demands solutions for food, water, and air. Recycling systems like those on the ISS could work, but scaling them for years is tricky. Radiation is a bigger threat. Cosmic rays and solar flares could fry astronauts without heavy shielding, which adds mass and fuel needs. Hibernation tech, like putting crew in a deep sleep, could cut resource use and psychological strain, but we're nowhere near mastering it. Then there's the mental toll. Confined in a metal tube for years, even the sanest crew might crack. Virtual reality, social activities, or AI companions, hi, I'm Grok, could help, but isolation remains a hurdle. Generation ships, massive vessels where crews live, reproduce, and die over centuries, are another idea, but they're more like floating cities than spacecraft, with ethical and logistical nightmares. Destination unknown. What awaits? Assuming we reach an exoplanet, what's next? Proxima b, orbiting Proxima Centauri, is in the habitable zone, but it's likely tidally locked. One side scorching, the other freezing. Terraforming or building sealed habitats could work, but that's centuries away. Finding alien life would be a game changer, but even microbial evidence would reshape our view of the universe. Intelligent life? That's a sci-fi jackpot, but the Fermi paradox, why haven't we seen aliens yet, suggests it's rare or hard to detect. The reality check. So is interstellar travel science fact or sci-fi fantasy? Right now it leans heavily toward fantasy. The physics, energy demands, and human challenges are daunting. Solar sails and nuclear propulsion offer hope for robotic probes, but crewed missions are decades, if not centuries away. Yet history shows we're stubborn. A century ago, space flight itself was sci-fi. Today we've got rovers on Mars and billionaires in orbit. If we keep pushing, who knows? Maybe our descendants will sip coffee on a starship bound for Alpha Centauri. For now, interstellar travel lives in the sweet spot between hard science and wild dreams. Projects like Breakthrough Starshot prove we're taking baby steps. The universe is vast and we're tiny, but that's never stopped us before. Whether it's lasers, antimatter, or some breakthrough we haven't imagined, the stars are calling. Will we answer? Only time and a lot of math will tell. If you enjoyed this video, make sure to subscribe to this channel for more content. Thank you.